Okay, so basically the four areas I am going to cover part of test estimation and scheduling today. So basically estimation and scheduling, and then how the roles will be applicable in the scheduling, and finally how will be the cost will be derived, or the project cost or project financial will be derived for a testing engagement or testing project or testing part of a project, right? So basically these are the four areas I'm going to cover with today's session, as I mentioned already. So let's see. So, and it will be a kind of a bit of practical one. So while doing the session, I will use a little bit of Excel, and I will show how to do this mathematics as well. So, okay. So basically these are the four areas that we are going to cover: estimation, scheduling, roles, and cost. So we'll look at the estimation part of it very first. Basically, when you looked at the estimation, so there are two different type of estimation techniques. So before I'm going to deep dive on these techniques, so I think I will take some real world scenario example outside the software engineering or IT or testing. So basically, so if you looked at if you want to build a house, right? So if you are going to, or if your parents also, if you have maybe sisters, brothers already built some, probably build their own houses, right? You might have some kind of experience or exposure on it, right? So, oh, I think future, if you are going to do that, that definitely this knowledge will require. So basically, there are few ways, right? So basically, you will get the plan uh, ready from an architecture or technician or someone who will draw the plan. So then the base of the plan, you will do a estimation, and the based on the estimation, you will plan your house, whether you want loan or not or something like that. You will find out what will be the final cost and how long it will take, and what kind of resources you will be going to use, and all those things will be planned based on the initial plan that you are going to derive via architect or technical officer or someone who know the subject, right? So that's basically how we are doing it. But when it comes, once you have the plan in hand, you can do a you can find out the estimation how much of effort will required, and how much of bricks will require, sand will require, cement will require, so that you have to estimate. So one thing is, you can uh, derive these matrices based on some form. So if you think, if you are uh, working for a large organization, right? So like a construction company like Maga or Sunken or something like that. So they will have some sort of existing data. So that means they might have done this business last 50 years, 20 years, 30 years, like that. And they know, if you are going to build a foundation for a house using a concrete, for a 1 square meter, 1 square feet, they will need this much of cement. They will need this much of sand. They will need this much of uh, gravel, and they will know they need how many masons or something like that, right? For do that for a 1 square feet or 1 cube square feet. Or if you are going to do it from other bricks or something else, so they will know how much of it will require for 1 square feet. So that's based on their data. So they will have some kind of data stored on various different houses. If it's a single story, they will know this is the foundation. Like if it's a 2-story building, is this is like it's a business building, or it's something apartment or something, like it goes for a 10, 20 floors or something like that, then different values, right? So they will have large amount of all data that's stored, and based on that, they can derive some matrices. So they can say, so if it is this much of story building and this type of one, they need this much of concrete, this much of sand, this much of cement, and there will be very identified numbers based on their history and data. So basically, we call those kind of they can quickly do the estimation based on this data and some of the matrices. So they know how their masons work. So how much of effort they can produce a senior mason and junior mason and trainee, and like intern and all these different kind of people who they hire. They know how much of effort they can put, and they based on that they can derive even the duration and the number of people they can put it, and all this they can quickly based on the existing data and based on some of the matrices. So that's how they do it. So if they are going to do a building construction, that's how their estimation they will derive and they will given to the person who requests. So that's we call basically matrix based techniques. Based on the sum of the matrices and data that the organization has, they can derive that estimation. Or alternatively, if you are not going for a larger company like that, so if you are going to ask for a senior mason or someone who familiar to your family or you know person, so then you can show this plan to him, and we can ask how much of if cost will be, how much of effort, how much of masons required, and something etc. So basically how he is doing is he has some experience, because this is not my, maybe he has his during his entire lifetimes he must have worked as a masons various levels, and based on his past experience, by looking at the plan itself he might come and tell, "Oh, okay, I need this much of effort මහත්තයා මට මේකට දවස් මාස 3ක් මහත්තයා ඔයාට concrete ගල් මෙච්චරයි සිමෙන්ති මෙච්චරයි කියලා පටපට කරලා ඒගොල්ලෝ they will tell, right? So that's how they are doing it, right? So that's basically experience. He has his own expertise, but he can only do this, right? He can't do estimation for a road construction or something else. But for a house building, if he has experience on single story house or two-story house, he will do. But he might not be able to do 10-story, 20-story building, right? But based on the experience, it will be limited to his experience, but he will quickly do. So that's how it's happened in the real world, right? So if you're going to build a house or home or buildings, this is you derive. So if you have asked for a company or construction company scientifically work, so they will build up set of matrices. So if you go for a mason, he will do his based on his experience. The same theory will apply for the software. Right? So there are two methods. One is matrix based technique. So you have to use certain software matrices like burn downtown, defect removal models, and there are various models. So there are matrices and what number of defects raised for a past specific technology and number of client reported defects on these specific models and all those things. So there will be a certain large number. We can derive many matrices. We looked at what are those matrices later part, hopefully next session, right? So but there will be many number of matrices available. You can use these matrices and organization data. So if that organization use for software development CMMI model, so there are various standards. CMMI is one of main standard that we use for the developing software. It has level 1 to level 5. So some organizations certified for CLMI level 1, level 2, level 3, level 5 is the highest. So people who practice level 5 CMMI standards. So based on that, they can quickly tell their effort and estimation and everything based on those standards and matrices, right? So similarly, this organization will have the stored data. Last 5 years, 10 years, they might have done similar software development and similar technology or various technologies, and based on that, they can have various data points and various matrices, and based out of those, they could be able to scientifically derive. So that's a way, one way. So other way is, so either they have to use some expert judgment. Some projects sometimes the organization might not have the streamlined data or matrices, because this industry is, as I mentioned very first day, it's a very new industry, not like any other industry like construction or etc. Because of that, we may lack in the data, or we may lack in the matrices that we require. So because of that, uh, we might go for expert judgments as well. Sometimes you can find out set of people who know this estimation well on these specific areas, then we have to use them. But still, there are some scientific ways. So the planning poker, white band LP, all those are expert judgment techniques that we use. So we'll deep dive into how these techniques will work. So there are certain expert judgment or expert based techniques. So you can use like it's not like again randomly giving the number like how we do in the masonries, but there are certain techniques, even expert judgment techniques we can use, like matrix based techniques as well. So basically there are two different type of techniques, right? So these are the two things. So any questions, anything you want to clarify on this point? All good with. Okay, so we'll move on. So basically these are the two techniques, but we'll see what are the other matrices available a little later. But again, so whatever the estimation that you are going to derive, there are certain impacts, right? So if you are going to build a house, right? So the construction example I mentioned. So even if you derive the estimation, that estimation will change based on the materials you are going to use, right? So you plan to use Sansta cement, but you couldn't find, but you use some low level cement, and that impact your construction. Or you could not able to find correct sand, you just use alternative. Or you could not able to use the correct size of bricks, so you have to use some alternative impact. So material impact is there. And same time, you thought of use some experience masonries and PhD of people, but unfortunately you couldn't find. You use very junior people, because of that estimation get impact. And similarly, you plan to use some certain process so to build the foundation and build the slab and build the wall, but due to various constraints you could not able to go with that process, the defined process. You have to alter the process and do first floor first and go for a second floor for a later or something like that. You have to change your process, and it might impact. And similarly there are various ways, and sometimes when you start building, your plan get changed, because initially you thought to build a house with certain condition, but later you got different feedback for your family members, and you thought kind of defects or something like that. You change the walls here and there, and bring some additional windows here and there, and you might have removed some of the walls and rebuild it, and so many rework coming in, right? So that's again the estimation get changed. Similarly, software also have the same stuffs, right? So product characteristics. So that we it says risk associated product. What basically product means what is the application you are going to build. So application might have various kind of risks that we discussed last time. Or size, complexity, technology, and detail requirement clarity, and legal compliances, and many other stuffs will impact the product characteristics. That will impact the. Sometimes when you estimate at the time of estimation, you might not thought to those things, but when you start building it up, it might impact your estimation, and it might get changed. Again, development process, you might just define, you might use defined technique, but due to certain challenges or certain requests, you might have to move to the different processes. So you might initially thought of doing it waterfall, but later based on the feedback, you might as go for agile, right? Or something like that, right? So it then the effort will get changed, right? Or initially you thought of doing use certain tools, but the tool prices seems to be very high, and you thought of you might define to not to use these tools, build your own tools. So then the cost will be low, but the effort will be changed, right? So similarly, there are various factors, right? The process side, there are various factors that will going to impact for you. So that will have a certain impact. So other one, as I mentioned, people. So you initially might thought of to hire a set of experienced people, but unfortunately you couldn't able to find anyone in the industry, and you didn't have a correct set of people. Or you might have concern in your junior team. You might have concern in your leadership team, or you might have knowledge gaps. So some certain technology you need to know, but the team might not know. Then you have to train them and get it done. So that also impact. And the test results. Basically, as I mentioned, based on the test results, there will be a lot of reworks coming in, a lot of changes coming into the application, or various new requirement might come in, a lot of rework will come, right, as construction. So that's also will have a clear impact to the test estimation. So those are the four basic areas that will impact software estimation, software test estimation. That's almost equivalent to a real world other cases as well, as I mentioned. Okay, so we'll look at what are the different type of estimations available. Yeah, okay. So we have there are large amount of techniques. So I have selected set of few highly user which is used in industries. So these are set of techniques. So we'll deep dive these techniques later. So one is a work breakdown structure, the 3 point software estimation and functional point, distribution in percentage, wideband Delphi, or planning poker, especially planning poker we'll use in agile, and we will do a different session for agile as well, so and we'll deep dive that. So these are set of techniques, right? There are many. These are set of techniques I identified, but there are many other techniques as well. Okay, so we'll see what these techniques then. So work breakdown means, so if you have given a application, so you need to find out the work breakdown. So that means you need to, based on the work that you're supposed to do, you need to break it down to a smaller portion, right? So think, so I will get an example from one of the exercises I just thought of doing it at the part. Okay, so think you have been asked to derive estimation for this PICME application for these four windows. The first window is you need to select pickup and you need to select drop-off point and search the vehicle. So to the pickup, you can do either location fetch from the map or either you can give the coordinates. For the drop, even you can pick up picture from the map or either you can give the coordinates. Similarly, or you can type the address or something like that, and you can select pick up and drop off points and search it. So if you are going to uh, write these cases, so for this specific functionality testing, so you have to break entire requirement here into a smaller piece. So basically, pick up. So pickup can be in two ways: either selecting a map or either providing an address or either providing a GPS location or exact coordinates. Give me 1 second. Okay. So let me show some small way of doing this. Okay. Okay. So this is small example I just already. So you can have your functionality like this. This is what we call work breakdown. Fetch is the location problem, select drop off, select one way return, provide location manually, scheduling, location fetching, select app type. So likewise, so these are the first set of things that I find out for the this scenario. So selecting from the manually select and map and various way and schedule it. So those are the how we can break the work, right? So we call work breakdown. If we know the work breakdown, we can do the estimation. So basically, we can derive. So test this, fetch in the location map, how many test cases is required. So basically, we can say to enter manually or enter coordinates. So probably two test cases, something like that. You can mention how many test cases required. Select drop off point. So how many test cases is required to select drop off? You can put plus button and select it in the map, or you can type it. You can do it differently. You can do invalid tests here, right? So yeah, you can put in incorrect coordinates, and so here I find mention it as 5. These are some sample values I did it. So we can have this work breakdown for this window one. This is window one, and work breakdown, and then I estimated how many test cases we can write to test based on the based on the testing techniques that I mentioned last week. You can derive how many test cases, right? It will require. So that's how basically work breakdown structure will work. Right? So that is the work breakdown structure. Okay. So very straightforward one. You can derive your own breakdown based on the activities you're supposed to do, and after that you can mention how many test cases you can write. Based on that, you can figure it out your estimation. The second one is 3 point. So it's almost like a work breakdown structure, but what we'll do differently is we estimated for a three cases: best case scenario, most likely scenario, worst case scenario. Best case scenario is that means if you have a very strong team, so that thing everybody experts, everybody skilled team, so they can do it very fast. So that's the best case scenario. So most likely scenario is the regular one. You have a mix of team, experienced people, senior people, junior people, everybody you have. So that's usually happen in the real world, right? So that is most likely scenario. And the worst case scenario. So worst case scenario is, so you have completely green team. That means everybody new, everybody fresh. They don't have much experience. They don't have the software testing experience, prior experience. They are just passed out from the university, so they don't have any knowledge on this testing, something like that. So they are very poor team, right? So the technology perspective. So such a team, you will require a higher effort. So we estimate all these 3 points, and we will find out a something different number. So I will show how we can do that. So same as work breakdown, we have to find out the work breakdown structure. So then you can estimate average effort is first. So this is my effort. So 2, 5, 3, 5, something like that. So then I will find out worst case. If I have a very poor team, so though I initially planned so maybe 2 hours required for the fetching location from the map to test that. If we this is for general team, but based on my experience, so it's expert judgment, I am saying if I have given a worst team, that means a very poor team, then I need 3. Or if I have an expert team, then I can do by 1.6 or something like that, 1.5. So here what I have done is, I will share this Excel sheet once I have done it with you all. So what I have done is, so I use a formula. So I got the very first one. So this is the estimated test case count of the same I use the same number as average, and worst case I multiplied by 1.5, and best case I multiplied by zero point 0.8. But these are the numbers I derive based on the matrices I do have, right? But based on the organization that we are going to work, they might have various matrices. Based on their experience, they might say best thing they can do it 0.75 or zero point 0.6. So worst team they can do by 1.2, something like that. Those are interesting matrices. So different organizations based on their conditions, they will have different numbers and they can do that. Right? That's how it will be. So we can have the average effort for the entire work breakdown. We can have the worst effort. We can have the best effort. So then we can get the sum of this effort. But how I could derive the final value? The final value derived, this is the formula. So basically, I will uh, I will use the best case, worst case effort plus 4 times of average average effort plus best case effort. This is the formula. By using, you can get the value and divided by 6, right? This is the formula. Worst case effort plus 4 times of average effort plus best case effort divided by 6. By using this formula, we can get the effort, right? So this is how we will be deriving effort for a 3 point. Any questions, anything like that? Right? So this is how I will share this sheet. You can try it your own and you can try it. So this is how the 3 point estimation will do. We will derive the effort for a first we will derive the effort for a average, then we will derive the effort for the worst case and best case. So then use the formula and we will derive. So the final number is 71.4. So that's how it. If we use the work breakdown results only, then you will get the 68 days. But here you get 71.4 units. So this is how you will derive that, right? Okay, so we'll go back to the session again. So this is how 3 point estimation will do, right? If you have any questions, you can ask it quickly as while I'm doing the session as well. Right. So there's the functional point. The functional point is a little complex. So basically, most of the time developers use, but QA team also can use it. So what we are going to do is we are going to calculate all the points, external, internal points, integrated points. What are the various ways data sources connected, users going to connect the application. So we will derive a small chunk of functionalities based on the functional points that we call. So basically, it's like WBS, but it's not like a WBS. We will categorize the entire application as these connectivities and points, right? So functional behavior of the application. So based on the number of units you are finding out, we call functional points, total functional point. Once we decompose the entire application using functions and integrations, so you will get a number like 100, 200, 300, something like that. That you call functional points. 200 functional point, 200 functional point, 300, something like that. That will be your effort. So each functional point, there will be a certain industry standard base effort required. For test functional point 1, you might need 1 day. Then if you have 100 functional point application, you need 100 days to test, something like that. So that's how functional point estimation will derive. But you basically we use for a development, but not mainly for the testing. But we can use it. Still, we can use it for testing as well. So the distribution percentage. So this also will require when we are doing the estimation, because sometimes based on the industry experience, organization will know. So you are out of your total effort, 50% of effort required for test execution or something like that. 10% of effort required for a test case writing. Another 10% is required for a uh, environment setup or planning. Test reporting, another 10% is required, something like that. So if your effort is 100 man days, out of 100 man days, you can quickly say, based on your previous organization data, history, historical data or expert judgment, or either way, you can say out of 100 days, 50 days required for a test execution, 10 days required for planning, 20 days required for a test case writing, environment installation and setup, and another 5%, something like that. You can come up with these numbers. This you just can't come up with these numbers. You have to use industry data. Based on the data sets available, and you can have a bit more accurate numbers. So, and we can use these numbers and further derive our estimation. So as example, so the effort. So this is one example, right? So you can have a percentage. Test plan in 10%, test design in 20%, execution 40%, defect report in 10%, regression testing 20%. So final total effort will 100%. So I took based on my initial WBS, I found out my effort is using 3-point estimation. My effort is 32, right? So I found out for the first set of window, I have done estimation based on some hypothetical numbers. These are just hypothetical numbers just to use. But if you know the correct numbers, you can use it. So finally, I got the estimation 32. Right? This 32 is test execution. So I identified effort for a 32 as a test execution. But I know based on my organization or the industry, this is how the real percentage works. This is how the real percentage works. These are fixed numbers. So I found out the effort for this is 32. Now I know the percentage from my industry. So then I can derive rest of effort rather doing another WBS. So rather doing a WBS, I already done the effort for a execution, and based on the percentage, I know I can derive this percentage. Right? Basically, I multiplied divided by 40% and multiplied by 10%, right? So that's how I derived other numbers. So by doing that, we can find out other estimation as well, like this. And if you want to identify the performance test and security testing efforts as well, same way you can derive other efforts as well. Functional effort is 80%. So this is you good to know from outside here. So then this is the number. So based on that, you can derive. These are the percentage. Performance security, it's a 40%. Effort for the functional testing. The functional testing effort for this is something like that. This will be how you could be able to calculate, right? So that's how we are going to do that. Are you clear, or any questions out of it? If you know other numbers, if you other percentages, that's also you can derive. So I just put hypothetical numbers here. Okay, so let's move on to the. So other one is planning poker in agile. This is basically, I think you might play poker, right? Poker is a card game. So people use, especially universities, used to play these games, right? So poker game is just a card game, but we use this card game to calculate the effort in scrums, basically agile. So I will do a different session with agile, and I will do hands-on activity on this as well. So probably you can we can try do it in our classrooms and try this, right? Okay, so but just keep in mind this is a planning poker. Basically the we are using a poker card game and find out the effort basically that we used in the scrum. So but deep dive we'll do in separate session, so that hence I'm not going to deep dive now, right? Okay. Other one is white band Delphi. So that I will mention what is white band Delphi. So white band Delphi is a method that we use large team like testers, developers, QA leads, and QA engineers, PMs. So we will have a large team. If we have a large team, we will do, we will individually, we will ask everybody to uh, derive the estimation. And in the first round, we will ask everybody to show their estimation. So in like here, people will tell. So some will say yeah the estimation in between 500 to 100. Some will say the estimation in between 1000 to 1005. So various distributions, right? Likewise. So then we will ask them to go back to your seats, redo your estimation, come back. But you have to do alone without showing to anyone. So the once round two complete, the people will come and show their estimation like this. But still some deviations. So we will ask, go back, do, and come back. Individual. So then the people will try to optimize themselves based on the previous knowledge they got from others. They will come up with like this. Again, there are some distribution. So then we will ask everybody to go back and do the estimation. The last session of round 4, round 5, 6, 7, until you come to some conclusion, somewhat near estimation. So people will come with like this, or come with like this, or come with like this. Somewhere here, until you come to a very near number, you will do this rounding continuously until come to some common agreement. Once everybody come to a common bucket, we will wind up the estimation session, and we will get that number as the final number. So that's how we are going to use all the different type of people, like technical people, PMs, business analysts, QA, and all together, everybody will ask to do the estimation. So in the first round itself, everybody come to one single number. That's great. That then they will take it as unless until the final number arrive. So we will do continuous rounding and find out the last estimation, right? Effort. That's the wide band Delphi method that most of the industries still use this as well as if they have a strong team. Right? They have experienced teams, they will use this methodology. So basically, those are the key techniques that we could be able to find out in the industry. But there are a few more techniques, but these are very straightforward and very most of the industry use techniques, right? So, any questions on these? Or are we good with them? Okay. If you don't, if you have any questions, please ask. Don't hesitate to ask questions, even in the chat. Okay, we'll move on to the next topic. So basically, uh, so these are the areas that will have impact and different. Sorry. So these are the areas probably people can use as an impact or best experience things or best practices. So while doing the estimation, right? So again, these are uh, there are these are dependent on the teams, people, and organizations again, right? But these are few best practices we better to use, right? Basically, if we have the correct stakeholders, correct developer, testers, project management, it's easy to do that, right? Because if you have experts, it's easy. And if you have historical data, like large data sets on the previous estimation, different similar projects and matrices, so that's easy. And the correct breakdown structure, right? How to break down to a smaller manageable units. If you could do it correctly, you could come up with a correct estimation. But if you're unable to do that correctly, you might ended up with incorrect estimation. So how to break down the work is a kind of a skill. And if you have already breakdown structures for a testers development and things that can be reusable, so that will be also if helpful. And correct technique, whether we are going to use wideband Delphi or whether we are going to do the 3-point estimation, whether we are going to use planning poker or whether we are going to use percentage distribution, something like that, or are we going to use hybrid, including everything or something like that. So that's a technique. So that's one thing you need to decide based on your people you have, based on the experience you have, based on the various scenarios that you have in front of you, and various testing types, whether you are going to do unit test, integration, automation, and various testing types, and risk factors and complexity. So some complex applications we need to think what kind of effort will require, or how. So if it's a simple application, effort will get changed. So because for a complex application, if you are going to write a test cases, you might require additional time. Or simple application, you can do it fast, right? Something like that. And how much of regression we are going to plan, right? So based on the technology, based on the developer experience, you might expect large number of defects. Then you have to plan large effort for regression, retesting, right? So basically, retesting you need larger. But if you have a very strong development team, you know that they will not have much of defects. Your regression effort will be less because defect fix time will be less. And review. So how much of review work is required, right? So that we need to make sure the review capture. And team collaboration. If you have a strong collaborative team structure and teamwork, team model, so then you can do it fast. But if we have a lot of friction, teams like they are not working together, they have a lot of ethical problems and many other stuff. So then their productivity will be low, and you might need additional effort, right? How much of automation you are going to use, which tools you are going to use. Are you going to write unit test automated, or your functional testing automated, or which tools you are going to use, and how feasible of usage of these tools, all this impact, right? So there are many impactful areas that going to impact. These are the basically we can consider as a best practice to derive estimation, right? You need to consider so some factors basically. Basically, this is all about estimation. So, so if you know this correct model, and they can use a correct technique, and you can derive the estimation. Right? So once you derive the execution, then you need to identify the what are the correct roles that you need to put against these efforts. Basically, test manager, QA manager, test lead, QA lead, senior test engineer, test engineer, automation engineer, performance engineer, security engineer. These are the various roles, right, that we will have. But you need to understand which effort is going to map for the specific roles, because you can't uh, plan the test execution effort for a test manager, and you can have multiple test managers, right? You have to plan execution for a test engineer. You have to plan test design for a senior test engineer, right? So you can't plan test design for test engineers and put test engineers to that, right? So something like that. So you have to figure it out, correct roles, and based on the roles, we have to divide the effort. So by doing that, you can identify how many people you need for a specific role to do test this application. So that is like this. It's basically like this. So let me show that. something like that. If you have activity like this, test plan, test estimation, functional testing as test design, this is work breakdown. Test execution, defect reporting, regression, performance testing, security testing, mobile component testing, process testing. This is your work breakdown. So now you know the estimation based on the previous uh, sheet. So I know these numbers. This is my estimation effort, right? So every task, everybody can't do that. Test planning and test estimation, lead has to do that. Or QA manager has to do that. QA lead or QA manager has to do this. This designing, senior engineer will do that. Execution, reporting, regression, this will conduct by engineer. Performance testing and security testing, definitely we might need a senior engineer like this to do that because that's experience. Mobile compatibility, cross browser, these are very low level testing. Any engineer can do this. You need to identify which task can be done by which person, right? Lead. So I identified here either lead or manager, right? So some of the other activity I have not mentioned here is probably you can have like activity like review test case. So those are review test cases. Then review result. So something like that. And you can add mentor review. So that's also required, right? So this maybe might be lead manager roles, right? You have to find out the effort for that. So maybe review effort will be the 10% of test execution. So maybe 30% of, or maybe 40% of this, something like that. Then you can find out. Mentoring will be the total effort. So out of the entire total effort, maybe 10% of it. And then you can find out. So this is are two additional things that you can do. And then I'm not using it now because my numbers goes wrong now. So and after that you can find out how what is the effort for each role, right? So lead it will be 8 hours. Senior engineer it will be 96. Okay, here it's 96. The engineer will be sorry, senior engineer will be 80. Engineer will be 590, 502, right? 502, something like that. So this will be your number, right? So you can find it. So then you know total effort. So once you know the total effort, so you can say each engineer what is each role and what are the roles you are going to use, and each role what are the efforts. That's the part of role identification. So that's what you need to do. So basically, you should have this experience and exposure. So based on that, you can find out how many people you need, which type of roles you need. Then the third one is schedule. So how to do the scheduling, right? So scheduling is basically if you have 4 different activities and you have to keep a sequential way how we are going to do these 4 different activities. So then you need to find out what are the end date of each activity. If you know end date of each activity, you can plan it. Which activity comes first, which activity comes second, activity comes third, and which activity comes fourth. So you can arrange the whole 4 activities sequentially and plan it. So this is the scheduling, right? Basically, if you know, you can arrange your schedule, but you need to know what is your duration of application, right? So basically, if you're going to do this in real world, so you know this effort. So now you need to know what is your size, right? Basically, uh, so what is your duration? So think this project, your project manager asked to complete within 3 months, right? So project manager want to complete in 3 months. So how many days in a month? So basically, we will have 20 working days, right? If it is 3 months, so how many days? We have to multiply by 3. So 60 days. So now if you have given this 3 months window, then you know within 3 months you have to complete this activity. So basically, what you can do is you can get a large effort and you can divide it by 60, right? Once you divide it by 60, what you will get? So 8, you will get 8. What is this mean 8? So if you want to complete this engineer work within 3 months, that means 60 days, you need 8 engineers. That is your size of the engineer. The rest you can get it based on the effort. So 80 also you can divide it by 60. So then you will get 1 point amount you want. So then you don't have half persons, right? If you get 1.1, you get 1.1, then you have to use two resources. If you get zero point 0.5 or zero point 0.1, zero point 0.3, you have to use one resource. You can't have the half resources, right? So this is how we will estimate. So you can divide it, everything you can divide it by 60 and see what is the number. So this is a number, right? These are the numbers. So then you have to round up. So you will round up 1, 2. Since you are round up here, I will round up it for a round down it because to fair by everything. So because I have additional effort here, This is my team size. The team size is, what is the team size? So here it's a team size is 11, right? My actual team size is 11, right? So I need 11 member team to run this project, complete this project within the 3 months. So that's what scheduling basically, right? You need to find out how many resources you want and then you can do the scheduling. So then how you can do scheduling is like this. You know the resources now. You can put one lead here. You can put test design one senior engineer. You can put security testing one senior engineer. Post testing you can put one senior engineer. So that means same engineer you can put it here and but you have to parallel. Since you have two people, you can parallel. Parallel do the same. So two people. So you have 8 engineers. So you can do 8 engineers. You can plan it for a test execution here for 20 days. So then 11 days of test design, 20 days, 11 of execution, defect reporting, regression. So you can, and later you can plan for a entire 8 engineers for a mobile testing, something like that. So you can, similarly, you can plan like this. This is what we call schedule. If you know, right, if you know these numbers, how many leads you want and how many people you want, then and the duration you know, then you can plan, put it everything as a schedule like this. So that by developing this schedule, you can come up with a final test schedule that will require for your project. Right? So this is how we will do the scheduling. So is this clear how I derive this? So these numbers are not aligned to this because I just used the hypothetical number, but you can do it for the same number I have given this side, right? This is the structure, 8 people, right? So then, but what one thing will happen is, so when we are scheduling, there will be gaps within these some of the activities because all the activities you can't do parallel, right? you have to complete this design first, then you have to start execution, then you have to complete some sort of execution, then only you can start report defect reporting and then regression. So if you have a stable build, only you can do the performance and security. At least you need to complete certain number of testing. So we have to complete at least initial first cycle of testing to start device compatibility and cross-browse testing, because if it is not stable, no point of testing for these kind of different testings, right? Non-functional testings and other different testings. Because of that, you have to stable application. So you can't parallelize. Some tasks you can parallelize like this, but some tasks you can't parallelize. Because of that, even you divided by number of resources by 3 months, when you are scheduling, it will drag further. You won't be able to direct. Oh, and unless you have to increase the number of resources required. Here, because here I got 11, but actually when I'm completing my plan, at peak I need 16 resources, right? So why it happened was because some of the people I can't use here until I complete these specific tasks. So then only later I have to load those resources to the project plan. Because of that, so project plan, you have to put more resources at the latter part, not the initial part. Because of that, latter part you need additional resources than 11, but initial you need very few people. So that's actually how it will be happen in the scheduling. Right? Though we plan for a 11 team member from across 3 months, your resourcing you will require differently, like this. So if you have balanced your effort correctly, you can see project plan like this. So we call project schedule like this. Any questions up to now? So I will share this sheet with you. I think you have to do your own exercise. First figure it out WBS, then figure it out percentages, then find a number, then do the resource loading like this, then build your own schedule like this. Right? So then you will be expert of doing a schedule, right? By doing this. Any questions on this? So this is actually how it happened in real world software. Not only the test project, any software development project, any project manager, any software QA architect or software QA lead or manager will do. Everybody has to do. This is exactly how it is happening in the real world. But sometimes they use different tools like Microsoft Project Manager or Microsoft Primavera or something like that. Different tools, but the activity will be as this. Initially, we'll do the estimation, then we will move one by one like this. Okay. So if you don't have questions, we'll move to the next topic. So next one is the cost. So how to calculate the cost? So basically, there are various ways to do the cost. So most of the time we generate the cost based on the actual expenses, right? So how to do that? I will show how to do that. So right now we know we need one lead, one senior engineer, another senior engineer. Uh, these numbers are just hypothetical. I'm just putting this number. The requirement will be like this, right? So and how many months? So one lead will be required for 3 months. So one engineer one will be required for 2 months. Engineer two will be required for 1 month. Basically, I will put three, and finally I put number of days each people has to work. Right? I just put the numbers. Right? So then we need to calculate the rate card. The rate card means how much of uh, rate applicable for a day. So how we are going to calculate is we need to calculate the cost of the individual. So basically we need to calculate the cost using salary. So other benefits, maybe bonuses or something like that. Right? Pension, so maybe EPF, ETF, the transport cost, the laptop cost, because laptop has to be given for any engineer, internet cost, desk, chair, space, meals, all these different costs. Right? So you have to have all these costs. Right? If you know all these costs, you can have a total cost, right? By calculating everything. Right? So then this is the total cost of this resource. If his salary is 100,000 and benefits are 20,000, pension is 8%. So this is, and transport is this, laptop cost is this, something like that, right? If you know this everything, you will second. So if you know all this effort cost, you can find out the final price. So this is the final cost of engineering, right? So then you can convert daily price because by dividing into 20. So this is the final. So he will work 20 days. For a day, engineer cost is by dividing this into 20, you will get 1907. Right? You can convert into a dollars by dividing into 300 or something based on the current rate. So then you can get the daily rate. So $23 per day. Right? Basically. So but this is the cost. But as an organization, you need to have margin. That means your profit. So if you are going for a 50% profit margin, so you need to double it. Like 23 should be 46. If you are going to 100% margin, you need to multiply by 4, right? Or something like that. So you have to multiply, you have, based on your margin that we're expecting, you have to. So here I assume 50% margin. So 50% profit is expected by this organization, because of that is 46. By rounding up, I find it out as 50. This is the rate card. So you can find out the rate card. So once you know the rate card, you can put these are the hypothetical numbers again. Like you can put it the rate card here, and then you can find out the price. The basically this is the rate card here. You need to find out the rate card. Once you find out the rate card, you can put it here. So once you put it the rate card, you can find the final price. So lead 12,000 USD, right? Uh, Senior engineer 1 6,000, senior engineer 2 3,000, rest of engineers 4,000. So your total project cost is 25,000 USD. This is your cost you come up with. This is including your margin, your profit. But if you want to give a discount, if your client is telling your cost is really high, you can reduce your margin here, right? You can reduce the margin here, and you can go for a lower rate card. Right? But you can go below. You can go below. You can go below 23 because that's your cost. If you go below 23, then you will be bankrupt, right? Because you will go minus. So that's the bare minimum number, but you can increase up to what number you can go up. That way you can select your project. So I take it as 50, or you can have various numbers like this, and you will get the final. So this is cost. This is how you can derive your cost. Okay, we'll go back to the slide again. This is how we can derive our cost, right? So basically, this is formula, right? This is what I did in my Excel sheet. So you can have a multiple hours and hourly rate, or multiple days and daily rate, and price, get the cost. So you have the final cost. So using that cost, you can sell your project at a given defined price. Okay, so what you have to do you at home is, so I use this for UIs, and out of this four I actually did this for a one, right? This is the one I did. So do the same repeatedly for other windows, second and third and fourth windows. That means these windows, right? Do the same exercise for other windows and try to find out the correct estimation and derive until up to the cost. Right? So that's what you need to do. Try it your home, then you will learn this estimation very quickly. So that knowledge will require to submit your assignment as well, right? So we will do it as a hands-on session at once we complete all these initial 5 sessions. But you need to have this knowledge, right? So hence try your own this exercise. I will share the Excel sheet as well. I already put the deck into the LMS. I will put this sheet as well to the LMS. So you can use it and do it your own. Right? So that's the exercise you want to do it today. Any questions? I think that's all I have to do for today. Any questions or anything that you want to ask? No? So then if you don't have any questions, just try this quiz. This is again the basics of the content that I shared today within this session today. So try it your own and make sure you learn what I want to share with you all. By doing this, it's okay with the either use the ChatGPT or Google or whatever thing. Try to find out the correct answer so that it will make sure you understood the session correctly, right? Hence, try this, right? Don't skip it, because by trying this, you will ease it. You can do it even while traveling, or you're traveling by train or bus, or by going home anytime, right? Even the midnight or whatever time. Just few 10-20 minutes will require, right? Maybe 10 minutes maximum. So by doing this, you will get the understanding what we learned today. So to make sure that, so try this, right? Don't skip it. And by trying this, you can easily do your final exam as well, right? As I mentioned, this is a one of easy subject to score, get higher scores and better G. So if you want look for a better GPA or higher classes, this is one good subject to score more, right? Okay, so if you don't have anything, that's all I have to share today. Do you have anything? So I